Hello, students. You're welcome to my class today. In our last class, we have successfully completed permutation and combination. It's time to move on to propositional logic. At the end of this lesson, students will be able to identify a proposition, learn about propositional logical resolution. Now let's proceed to the next page, having stated our learning objectives. Now, what is a proposition? That's the first question we need to ask ourselves. What is a proposition? A proposition is a basic building block of logic. It is identified as a declarative sentence that is either true or false, but not both. A proposition is a declarative sentence that is either true or false. If you can assign a true or false answer to a statement, then it is a proposition. Then if you cannot assign a true or false, then it is not a proposition. That's what proposition is all about. Now look at an example that we have below here. The sun rises in the east and sets in the west. Sun rises in the east. That is a true. That we can give a true answer to that. Then is a proposition. 1 plus 1 is equal to 2. And that is true. So it's also a proposition. B is a vowel. Of course, we know that B is not a vowel. Then we know that is false. Since we can assign a false, then we know this is a proposition. Good. So all these three examples that are here, they are proposition. We can also call a proposition a statement. A statement. Okay. If you can assign a true or false to a particular statement given, then you know that it is a proposition. And if you cannot assign a true or false answer, it is not a proposition. Good. Now let's see what we have again. All of the above sentences are propositions, where the first two have valid true and the third one is false, as we have seen. Now let's see examples that are not propositions. Those are the next three that we have on this slide. This example shows that they are not proposition. What time is it? That's a question. A question is not a proposition. Take note of that. Question is not a proposition. Go out and play. That's a command. A command is also not a proposition. And as you can see, we cannot add or give an answer of true or false to this question. What time is it? The answer is not true or false. And because we cannot give an answer of true or false, then that becomes is not a proposition. So that's not a proposition. X plus 1 equals to 2. Because we don't know what x is, the third example here now, because we don't know what x is, so we can't say if it is equal to true. Do you understand? So that is not a proposition. Once an answer of true or false is not specific to a particular question, to a particular statement, then it is not a proposition. So those sentences cannot be assigned a true or false. So that's the reason why they are not proposition. Now let's quickly see what we have next on our page. Now anytime or the area of logic which deals with propositions is called propositional calculus or propositional logic. Once we are treating anything that has to do with proposition statements, then we are dealing with propositional calculus or propositional logic. It also includes producing new proposition using existing ones. Propositions constructed using one or more propositions are called compound propositions. Now, before we say compound, we need what we call logical operators or logical connectives. The connectives or the logical operators are the symbols that we make use of to form what we call compound composition. Just like in English, we have what we call a compound sentence. When two simple sentences are linked with and, then it becomes compound sentence. The same applies here. We make use of a symbol when two statements or propositions are connected with a particular symbol. Okay, it becomes, or with symbols, it becomes compound propositions. Good. Now let's quickly see what operators are, logical operators, or what we call logical connectives. Both of them simply mean the same thing. Logical operators or logical connectives. Good. Quickly, the common ones, we're going to treat them, the ones that are required for this level so that we don't get out of the scope of this class. Number one, negation. Negation, that's a connective. If P is a proposition, then the negation of P is denoted by a symbol, that symbol P. That is looking something like this. When I put that symbol beside a letter, it means I'm negating the statements. Good. For example, P could mean Yomi is a boy. Yomi is a boy. If that is statement P, then if I put this symbol and add P to it, it means Yomi is not a boy. So once you see this symbol beside a letter, it means we are negating the statements or is a negative proposition. Good. That's what that is all about. Then we quickly need to know what truth value is. Okay. Now this table you can see here is what we call a truth value. Truth value is talking about we use the true or false symbol on truth value or truth table. Okay. Now if a statement is true, the negation of it, this negation of it means it will be false. If a statement is false, the negation of it means it's going to be false. Good. Now look at this example that we have here. The negation of this example here now. The negation of it is raining today is it is not the case that it is raining today, or simply it is not raining today. That's simple negation. That's how to negate a statement. Good. That's what negation is all about. Let's check the next one, conjunction. Yes. Now when we want to have a compound proposition, we make use of conjunction, and the symbol is exactly what we have on the screen there. We make use of this symbol. That's the symbol for conjunction. When I want to combine two propositions or statements, okay, we can use a conjunction. It becomes a compound proposition. This one of it. Good. That symbol is simply represents conjunction. Once you see that symbol, we are talking about conjunction. Now let's see what the truth table has. Now if I have PQ, then we have P conjunction Q. The conjunction simply means and. That symbol, which is this, the symbol simply means it means and. And that's what that symbol means. So wherever you see, so this is talking about P and Q. That is talking about what? P and Q. Okay, so the truth, this is the truth table we have for that. When P is true and Q is true, then it means P and Q is true. When P is true, Q is true, then it means P and Q must be false. Now when P is false, Q is true, then it means both of them must be false. And that is what we call truth table. This is the truth table. Each of these connectors have their own truth table, and take that as the truth table for conjunction. Now let's see what we have next. Look at the example. The example is just here saying today is Friday and it's raining today. Okay, that and in between them shows that it is what? It is a conjunction. Okay, so that symbol shows that P and Q, it is Friday and it is raining today. P is today is Friday, Q is it is raining today. So we have done a conjunction to the two statements. Now let's see what we have next, which is disjunction. Disjunction simply means or. That's what it means. When you see disjunction, it means or. That is, this symbol, it's synonymous to or, okay, as against the other one that is and. Okay, now what we have, the truth table. These are the things that are important in logical reasoning. Okay, when P is true, Q is true, then P or Q is true. When T is true, Q is true, then P or Q must definitely be true. When false is true or Q is true, then that must be true. Then notice it's only when both of them are false that we have a false. Okay, the table, that's the truth table for disjunction. Let's take note of that. Good. This is just giving us an example of conjunction. Thus, it simply means or. Today is Friday. The Q is saying, good. Today is Friday, that statement P. Q, it is raining today. Today is Friday or it is raining today. So what this statement means, if today is Friday or it is raining today, this is the interpretation. Okay, good. Now let's see what we have on our next slide. I'll quickly check other operative or connectors, connectives, or operators. Implication. Another name for implication is conditional. We use this to represent conditional proposition, conditional. So, and that's the symbol. When you see this symbol, we're talking about conditional proposition. Okay. Now, if you take notes, the ones that comes before, that is called an antecedent. The statement that comes before the other one, this P is my antecedent, or we call it premise, hypothesis, or antecedent or premise. While we call Q, we call it conclusion or consequence. Is all part of the notes we have there. So P, that is a condition for Q to happen. That's the meaning of this. P is a condition. This P is a condition for Q to happen. And that is what? The P is what we call hypothesis or antecedent or premise. So the Q that depends on P is what we call conclusion, and Q is called the conclusion or consequence. Okay, and the truth value is given below. Good. We are gradually getting to the end of this biconditional or double implication. Now, when the symbol goes like this, we have arrow at both ends. That is biconditional or double implication. So those are the names. So you see, and that means if and only if. Okay? If and only if. Now, let's look at its truth value for that particular question, for this particular proposition, biconditional or double implication. This is the truth value we have there. That's the truth value. Good. Now, the statement P Q is also called by implication. It has the same truth value as this. It means P is a condition for Q to happen and Q is a condition for P to happen. That's the interpretation of what that one is. We can interpret a biconditional statement this way. P is a condition for Q and Q is also a condition for P to happen. Okay, so that means it is vice versa. Vice versa. P is a condition for Q to happen and Q is also a condition for P to happen. So that's the interpretation of that. So if I have something like this now and have this symbol B, it means A is a condition for B to happen and B is also a condition for A to happen. So both of them are conditioned to each other. Good. Now let's see an example of that. This is the example I want us to see right now. It is raining today if and only if it is Friday today. Is a proposition which is of the form this. When you see if and only if, that's the factor. That is a key word that shows biconditional or double implication. If and only if. Okay. Now the above proposition is true if it is not Friday and it is not raining, or if it is Friday and it is raining, and it is false when it is not Friday or it is not raining. So when you see that condition, it means if and only if. If and only if. Good. With this, we've come to the end. I want each and every one of us to give me an example of a proposition. Check the pages that we have in this particular slide immediately after this video. You're going to see some questions at the end of each page. Make sure you attempt those questions. Put it in the chat box and I will respond to those answers that you have given me. Thank you. Till we meet again. The summary, of course, what we have done today is talking about propositions. We've talked about what proposition is. We've mentioned truth table. We've talked about different logical operators, which we also call logical connectives. Till we meet again, see you in my next class. Thank you, and make sure you attend the quiz that is connected to this class. Thank you.